Hello again. We're continuing with vectors. We're going to be talking about subtracting vectors, multiplying them, and dividing them. But before we get back to the notes, let me just show you a very useful website. It's called Math is Fun. And if you Google Math is Fun, it's fun vectors, you'll come to this page. And everything that I'm talking about here is covered by this website, and it's a very friendly way to learn math and vectors. I should also point out that these notes and also this Math is Fun website are not a substitute for going through the book. My notes and the book are different, which in a way is good. I'm giving you a slightly different perspective on the physics than from what the book does. Okay? All right, let's get to the notes now. So, subtraction is the same thing as adding the negative of something. I see a little typo right here. Right, something, missing the H. For example, 10 minus 3 is the same thing as 10 plus negative 3. So in the same way, if you you can do the same thing with vectors. Now, the negative of a vector is the vector turned around. So if this is b, then this is the negative of b. So continuing with this idea, a minus b, the vector a minus the vector b, is the same thing as the vector a plus the negative of b. So continuing with the same a and b example vectors as before, if I want to do a minus b, it's going to be, here's my a vector, the same as before. And originally, the b vector was pointing this way, but now it's the negative of b, so it's turned around. And I just go through the process of adding them. Here, it looks like I used the nose to tail method to add them together, and I got my answer. The answer is here, like that. Okay. All right. Multiplication. Now you can multiply vectors by scalars. So if you multiply the vector a by, let's say, 3, you're just making it 3 times longer. Now, there is such a thing as multiplying two vectors together. And if you go into the Math is Fun website, he'll explain that. There are two ways. There's the dot product method for multiplying two vectors, and there's the cross product method. And in physics, we use both methods, and they have different meanings. You can divide vectors by a scalar. So the vector a divided by 3, it would be actually the same thing as multiplying the vector a by the reciprocal of 3. The reciprocal of 3 is 1/3. And what that would do is make the a vector as 1/3 as long as original. Its magnitude is reduced by a factor of 3. Let's talk about unit vectors. Unit vectors are special vectors that have a length of 1. That's their definition. That's why they're called unit vectors. And when you write a unit vector symbol, it gets a hat instead of an arrow. So for example, this is a hat. It's a vector of length 1. Now we have some special unit vectors called x hat and y hat. And the x hat unit vector points in the x direction, and the y hat unit vector points in the y direction. And here I've drawn the x hat vector and the y hat vector. Okay, I'm going to erase them because that's sort of in the way. Now let's have an example of using the x and y hat vectors. We're going to use them to represent the vector b from previous examples. So yeah, okay, here is our vector b, and first we decompose it into an x component. So here's b sub x, and here is b sub y, and this one has a length of 0.8 centimeters. This one has a length of 2.9 centimeters, and we can say that the vector b, this vector here, is equal to, here, let me write in b like this. So b is equal to that length b sub x, the x component length, times the x hat vector. And I'm adding to that the length of b, the y component, and multiplying that times the y hat. So the process here is, for example, let's consider the y one. Okay, so the y hat vector is like this, but then when you make the y hat vector 2.9 times longer, now it becomes this long, and so you have the right thing here. You've got the y component of b. And so now you've got these two components. You've got the horizontal part, you've got the vertical part. You add them together, and you've got it. You've done it. You've got the b vector back. All right. Now, a little note. Our book uses the notation x hat and y hat, and that's fine. But most other books use I hat and j hat. So historically, this is the notation that physics books have used. Our physics book, which is really pretty good, decided to use x hat and y hat. It's more logical, but it is different from the other physics books. I need to do another example to show you what use this is. So let's do the second example here. So we have the a vector from previous examples, and we decompose it into an x component, which is 1.4 centimeters long, and a y component, which is 1.4 centimeters long, but it's in the downward direction, and so you have a negative sign here. And okay, so the a vector is the length of the x component times the x hat unit vector plus the length of the y component times the y hat unit vector. And so you have this becomes the x component, and this is the y component. And you put these two things together and you get back the a vector. So what we have here is a way to represent vectors with numbers. So here's the number 1.4, and here is the number negative 1.4. And this is important because this lends itself to video games, computer simulations, and this is really the way most real physics is getting done these days. It's with this sort of representation of vectors, of force vectors, motion vectors, and so on. Okay, so now let's look at how you add these, add two vectors using the x hat and y hat components. So this method is really the same as method 3, but we're we're taking it a little bit further in the direction of putting in numbers. So this is method 3, upgraded slightly with all these numbers. So the example was we are adding vectors A and V. We're doing A plus B, and what we're going to do is write down the A vector. We're going to use this version of the A vector, A sub x, the x component times x hat. And so you see here I have the x component times x hat plus the y component times y hat. And we're adding to that plus the b vector, which is the x component of b times x hat plus the y component of b times y hat. All right, and we continue. Now we're going to rearrange things. So we group together things that are multiplying x hat. So what's multiplying x hat? Well, it's this one here, a sub x and b sub x. So we have a sub x plus b sub x times x hat. All right. And here we're grouping together the things that multiplied y hat. So we have a sub y plus b sub y times y hat. Don't forget, these are the x components of the a vector and b vector. These are the y components of the a vector and b vector. Now we add so now we have the numbers for them. Okay, so a sub x, the x component was 1.4 centimeters, b sub x was 0.8. And then we're going to add those. So 1.4 plus 0.8 gives us 2.2. And now we're going to do the same thing with the y components. The y component of a was negative 1.4 centimeters. The y component of b was 2.9. We're going to add negative 1.4 plus 2.9, and we get an answer 1.5 centimeters times y hat. So now we have our answer. So here is the x component. It was 2.2 centimeters in the x direction. Here is our y component. It's 1.5 centimeters in the y direction. And now we add those two together and get our final result. Like that. So I believe we are done with my notes for chapter 3. Our textbook does have more information, more useful examples, and so you have to study the textbook and and understand how to use vectors. We're going to be continuing our study of vectors and how to use them in the next chapter, which is about two-dimensional motion, and in particular about projectile motions. Okay, so see you next time. Thank you. Bye-bye.